Good evening, Seshan. I will continue until the others join today. You don't have any problem today, right? No power cut or anything? Ah, really? Okay. Okay, so you can continue, right? Shall we start? Right. So the previous, I have discussed 7.1 and 7.2. That is alkane, alkene, and alkyne, and aliphat, halogenated hydrocarbons, the IUPAC nomenclature or IUPAC names. Now the next group of organic compound, alcohols. Alcohol. Yeah, that's all right. I'll explain the theory and then we'll do it. Yeah, don't worry, Sishan. Because after unit 5, then we have inorganic. Have you done inorganic SPD blocks? Okay. So inorganic chemistry you can't do until you complete everything, right? Because you are getting from a combined questions S block and P block you have to complete, because questions you don't get only from group 1 or only from S block. That's why until you complete inorganic chemistry completely, we can't handle the questions. But right now, organic chemistry is not like that. IUPAC names or the naming of organic compounds we can discuss separately. It's not a big issue because I can explain. I have already shared with you this organic short notebook. Organic short notebook. You have this, right, and the resource book also you can use. So here I have given the priority order, like when writing the names of organic compound. So if COOH group is there, then it's a carboxylic acid. Name ends in oic acid, like that. Now here you can see the OH group. If we have OH group in the carbon chain, then the name it's an alcohol. The name ends in ol, methanol, ethanol, propanol, butanol, pentanol, hexanol, like that. And if it is a side group, then we call it hydroxy, OH group. OH group, the functional group, it's an alcohol. OH group, side group or substitute group, then we take this as hydroxy. So example, now most common one, ethanol, ethyl alcohol. The name, given the number of carbon atoms in the chain, then root name or the prefix. So we can write metheth, prop, but, penta, hexa, like that. Example, methane, methanoic acid, methanol, methanol. So like that. If it is an aldehyde, okay, I'll give one example. Yeah, functional group means actually it is the organic compound. Its properties based on the functional group. Okay, I'll explain that also. Don't worry. Okay, you can see the screen now. Now example, you take here. You can see this white background, right? Yeah. Now look at this CH3. So I'll take here CH3, CH3, CH3. We'll say like this CH3, CH2, CH3, like that. So what is this? It is propane. You had done in oil chemistry also. This is propene's 3 carbon. It is propane. Alkane, alkane. Now, if I put a double bond here, CH, CH, double bond, CH2, that is called propene. Propene. Because there's a double bond. So if you write here CH3, CH, triple bond here, it's become propine. Here no hydrogen, just carbon because around carbon. So this is propine. If you only can note down this in a writing book. The green gas has propane, Completely green gas means, I mean, you mean the LP gas, or what did you mean green gas? It's propane and
Sir,
butane.
that they just inform us the reason that's like green gas cylinders.
Yeah, cylinder in the sense our LP gas cylinder.
Yes, sir, LP gas
Yeah,
in
correct, correct. Yeah, LP gas cylinder contains propane and butane. It's a mixture of propane and butane.
sir, but I checked in internet, then just like the green gas cylinder is not as same as the normal cylinders. The green gas cylinder. It says that it is completely only propane, sir. That is how I got the
Oh,
information.
yeah, yeah, must be because in our country we are not using that like that one, but different countries they must be using different proportions or different gases, different composition, correct. But in one like the green cylinder, so actually it's the what matters, not the color here, because in Sri Lanka also we have blue and the yellow cylinders. But actually LP gas, if you take, it consists of mainly propane and, because propane also can be used 100% as a fuel. It's propane and butane. It's a mixture of propane and butane. So butane about 70% and propane is about 30%. That's how you get it. Propane 30% by volume and butane 70% by volume LPG. So it's a group of mixture of hydrocarbons, alkanes, mixture of alkanes. But yeah, as you said, the green cylinder, it can contain 100% propane, no problem. They all can be used as, all the alkanes can be used as fuel, petroleum. Then next one, if you take here propanol, if I want to convert this into alcohol, propanol, CH3, CH2, CH2OH. This is called propanol. Propanol. If you only can tell CH, if you reduce the carbon chain, if you want, you can write CH3, CH2OH. This is ethanol. Ethanol. So you ask what is functional group? Actually, functional group means what? It depends on the properties of this organic compound, depends on the OH group, not based on the CH3, CH2. So OH, because of OH only, it's become alcohol. Now I think you understood what is the meaning of functional group. Functioning of the compound depends on this functional group. So example now, this propane, propene, propine, it depends on this double bond and triple bond. So therefore the property is mainly based on this, the existence of double bond, existence of triple bond, existence of OH group, like that. Here this is prop means 3 carbon, propanol. So if I want to convert this into aldehyde, then you can write propanal. CH3, CH2, C double bond OH. This is aldehyde group. That is called propanal. Prop means 3 carbon. This is the functional group is an aldehyde. So if it is an aldehyde, the name ends in L. Propanal. L. I'll highlight that. So this is L, propanal. Propanol, OL, all, alcohol, is ine, a triple bond, alkyne, ene, a double bond, alkene, and ane, ene, ine, all, L. Then if it is a ketone, so if you only write here, this is, you better copy down this in your writing book, then you can have an idea what are the groups of organic compound. So this is alkane and alkane. So this is just one example and alkane. This is alkene. Alkene. This is alkyne. Alkyne. This is alcohol. Alcohol. This is aldehyde. So therefore aldehyde is the functional group is this C double bond OH. That is aldehyde group. And anyway, in all these the around carbon there must be 4 bonds. If you want to convert this into CH3, CH2, say if you want to convert this into ketone, then there will be double bond O oxygen. That means C double bond, here in the middle you get, this is ketone. This is called propanone. Propanone. The name ends in on, O-N-E. That's called propanone. It's a ketone. So this is the functional group here. That is a ketone. So I'll write here within bracket, it's a ketone. And if you want to convert this into carboxylic acid, so I'll do this CH3, CH2, COOH. So in all this, what is common? There's 3 carbon. That's why the name, the prefix prop like that. So this is propanoic acid. Propanoic acid. This is a carboxylic acid, like ethanoic acid, like that. If it is, if there's 2 carbon, if then CH3COOH here 2 carbon, then it's become ethanoic acid. Ethanoic acid. So this is 3 carbon, therefore propanoic acid. It belongs to which group of organic compound? Carboxylic acid. Carboxylic acid. Okay. This is a carboxylic acid. Carboxylic acid. Okay, did you get an idea what is the meaning of functional group then? The function of the compound depends on this. The main group, or we call it the functional group, not based on the CH groups. CH3, CH2 or CH3, CH3, that they don't mainly affect the functional, the properties of the compound depends on this. Because of COOH group, it becomes polar. Because of COOH group, it's form hydrogen bonding with water. Because of COOH group, it's getting dissolved in water. Because of COOH group, it shows acidic properties. It's carboxylic acid, like that. So did you get the? Is that clear?
Yes, understood. Sir, how to identify? Is it so you have put there in a corner ethanoic acid? How to identify is it ethanoic acid or not?
Yeah, if there's a COOH group, it is an acid, carboxylic acid. If COOH group is there, it is a carboxylic acid. And
Okay, sir.
Because it come because of 2 carbon. It because of 2 carbon.
Okay.
Right. Shall I erase this? Did you finish copying down?
Okay, sir. I copied all of it.
Right. Then now let's see that the naming of alcohol. So because actually I have prepared this IUPAC names of organic compounds. First I did, okay, I will share that also. Unit 1 organic compounds. 7.1, I think, did you, I don't know whether did you join that day when I started this? This is aliphatic hydrocarbons. This is alkanes I did. 7.1 we have done. Have you completed this? The note? I mean, these names.
No, sir, I was unable to get to this class, sir.
Yeah. So then I will. I think I shared with you the recording, right? Or
Yeah, sir. I watched recording too, sir.
you haven't watched that, right?
No,
Yet.
I watched, sir. I watched recording already.
This one you watched the recording and then you completed these names.
Names, no, sir. I couldn't take the printout still of that.
Okay, okay, right. Okay, then if you need to watch the recording again, let me know. Then I'll recover and send it again because you
Okay.
have to recording and complete the write the names.
Okay, sir.
1.2, that is alkenes and alkynes. The writing the names of alkenes and alkynes.
Okay, sir.
Then 7.1 about alkanes. How to write the names of alkanes? Because every year you get a question definitely from this in the LL paper. That's why. Alkane.
So I completed 7.1, but 7.2 I haven't completed still.
That's why. 7.2, nothing new. The only thing is when you write the names of alkenes and alkynes, you have to give the priority to the double bond and the triple bond.
Okay.
When you start numbering the chain, you have to give the priority to the functional group. So the functional group is the double bond here. Like actually, it's you have to start numbering, giving the lowest number to the double bond carbon. Then 1, 2, 3 like that. You have to select the longest chain containing maximum number of carbon atoms, and when numbering the chain, you have to give the lowest number to the double bond carbon. Then this 5 carbon in the chain. So then is
Yes, sir.
right pentene, actually pentene, because you can't write pentane because it's an alkene, pentene, but it's not the complete name because there are 2 other side groups attached to this, right? I'm just summarizing, but anyway you can watch the recording because without this you can't understand the today's alcohol IUPAC names. So this CH3 CH2 group, this is called ethyl group, and this is called methyl group, right? So these 2 groups, methyl and ethyl, they are attached to the second and the third carbon of the chain. So when writing the name, we have to write the side groups first, or the substitute groups first. The side groups attached to the main carbon chain, we have to write at the beginning of the name according to their alphabetical order. So what should come first here? Ethyl. But you can't write just ethyl, you have to indicate to which carbon it is attached. So it is 2-ethyl dash, and the other side groups attached to the third carbon of the chain, methyl group. So we write here 3-methyl. Right? After that, you write the root name, that is propene. So we can write here prop dash 1 in. Why 1 in? Double bond begins at the beginning of the first carbon. Double bond at the beginning of the first carbon. Is that clear?
Yeah, sir, it's clear.
So this common thing, so it's applicable to any other organic compound also. You have to find the common standard. So the common rules, it's common to other organic compound also when you're writing the names. Now example, now this is you are writing the name of alkene with 5 carbon, but other organic compound also, first you have to write the side groups or the substitute groups at the beginning of the name according to their alphabetical order, not the number to their to which they are attached, the alphabetical order. But anyway, number 2 come first before number 3, but because of the ethyl group here, actually not because of number 2, we are writing that the first. We are writing ethyl first not because of number 2 here, because of alphabetical order. E comes before M. So 2-ethyl, 3-methyl. Then the other most important thing, we don't leave any gaps here between the letters. Between letters and the numbers, no gaps. Around the number, you have to put a dash, right? Not commas, dash. And all the letters you can write in simple, right? All the letters in simple. If you want, you can write the first letter capital, no problem. But in general, we write normally all the letters in simple. So anything else that you want to clarify here? I'll go to the next 7.3 now then.
Okay, sir.
Then 7.0, so that is nothing new, the same procedure. The name ends in all. Alcohol, in alcohol, I have given here 3 groups of compounds in this tutorial. Alcohol. Now this is the issue now. You all are having now this October, this 2022 A-level batch, 2022 A-level batch, they are doing the exam in this October. Now I don't know whether they will postpone this again or not, they have not confirmed it, but some of them, they are still in the first the grade 12 work they are doing, right? Organic chemistry. So grade 13 they have not touched some of the students in school, like anyway not possible, but even in classes. Therefore now you can imagine until the last minute, if you are doing the last few lessons, then you don't have time to do the revision, you don't have time to do the papers. That's why I thought of the same issue, like with the I am doing the 2022 batch this October, the A-level batch. So still I couldn't start the last 3 lessons, so the physical chemistry, the hardest lessons, because they haven't done the theory. So then what I did was, so I started giving a summary, short note, and then doing the questions. Now they are doing it, they can manage it. So that's what I'm planning to do your batch also, because organic chemistry unit 7 to 10. So that's no balancing, no calculation, no equations, like no byproducts you have to memorize. So it's in organic chemistry, it's easy to do the revision before inorganic chemistry. That's why I thought of doing organic first. Inorganic chemistry, you have to write all the products and oxidation numbers and everything you need balancing. It's a bit more complex, and you need to complete the theory before I discuss the questions there. That's why. But organic you can understand, so that's otherwise I don't do it, right? So now first alcohol, and then after that we are going for the aldehyde and ketone. I have did you get the printout or this short notebook? Organic chemistry, I have shared this short notebook.
No, sir, I couldn't take that. But I have a soft
I
copy
think
of it.
you have the soft copy now. Okay, that's all right.
Yeah.
If you have the soft copy in your leisure, you can take the printout. Now I have shared this also with your WhatsApp group, right?
Okay, sir.
Then okay, let's write the name of this one, alcohol. So alcohol you can write CH3 CH2OH. So actually this is the most common alcohol we use. If it is CH3OH, we call it methanol. Right? Methane, one carbon, methanol. Methane, actually it's if it is CH3 CH3 is if it is CH4, it's methane. Methane. So what happens here? We methane. We cut E, the last letter, and make it all methanol. We omit the last letter E and we make it methanol. So this is actually, if you make it CH3 CH3, it is ethane. So ethane, now I have converted this into ethanol here, because one OH is replaced by OH group. One hydrogen is replaced by OH group. Then it's become omit the last letter and make it ethanol. Right. So both these alcohol, because what is common to both is this OH group, the functional group. If you want, you can write ethane 1, because OH group can be anywhere. Now when you look at this third example, you can see that clearly. If you want, you can put the OH group at the terminal if you want. Say example CH3 CH2 CH2OH. There are 3 carbon, but here both this you can see the same chemical formula, right? C3, how many hydrogen here? 3, 1, 4 plus 3, 7. This is also 7, right? 4 plus 3, 7. So both is having the same number of the chemical formula, same. C3H7OH. C3H7OH, both this. But it's, even though the same chemical formula, the position of the OH group different. So actually next, that's what we are going to discuss next part in this organic lesson, that isomerism thing. For the same chemical formula, there are 2 different structures now. Therefore you can write both this. You can write the after 2 carbon you get 3 carbon, then it's propanol. So both this propanol, but it's different, no? The OH group, the position of the OH group different. That also you have to indicate when you're writing the name. So example, this is propan 2-ol. This is propan 2-ol. 1, 2, 3. The carbon chain you have number. So this is also when numbering, you have to give the lowest number to the functional group carbon. 1, 2, 3. So both these now propanol, but the first one is what? Propan 2-ol, because carbon OH group is attached to the second carbon. OH group is attached to the second carbon, therefore we call it propan 2-ol instead of just plain propanol. But this one you can write just propan 1-ol. Both is propanol, but they are different structures. The functional group attached to different carbons of the chain, like not the same carbon. Is that clear?
Yes, it's clear.
But this one actually it's not necessary to write the previous one ethan 1-ol, because either you put if you want, you can put this side OH group CH2OH, this CH3 CH2OH this way, right? CH3 CH2OH, both this, so it's ethanol, because you anyway the OH come to the terminal. If you both this same actually, because you can turn this by 180 degrees. It's the same structure. Therefore, it's not necessary to write the first two methanol, ethanol. So just write methanol, ethanol, but propanol is the number to which the OH group is attached. Then, shall I read this? Did you finish copying down?
Yes, sir, I copy.
Then number 3. Number 3, it's how many carbon in the longest chain? 4 carbon. Look at here, there are 4 carbon in the chain. So then you have to, what is the second step? You have to start numbering the chain. 1, 2, 3, 4. Right, that means butanol. This is butanol. You can write butanol, no problem. Since OH is at the very beginning, on the first carbon, butanol. Or you can write butan 1-nol. Actually, this one is better. The one that I have put within bracket, butan 1-nol. That means what? OH group is attached to the first carbon. Because you can put the OH group on any other carbon here. If you want, you can put the OH group on the second carbon. If you want, you can put the OH group on the third carbon. Then if you put the OH group on the second carbon, it becomes butan 2-ol. Did you get the point here? Now, if you want, I can change the position of the OH group, but still it will be an alcohol. It is an alcohol. So I'll put here CH, here OH, and here CH3. What is this now? If you start numbering the chain, lowest number from one end, so when you is number 2 here. If you want, you can start numbering from the left side, then that is not suitable. Why? Because OH group get number 1, 2, 3 here. OH group get number 3, but the red one OH group get number 2. So we have to give the lowest number to the functional group when numbering. When numbering, we give the lowest number to the functional group. So you can write here then. So what is this one? Butan 2-ol. Butan 2-ol. Butan 2-ol. Butan 2-ol. Right? That's how you get it. Then can you try the fourth one without my help?
Sir, for this it come to for this one again, two hydroxy, no, two all that butanes, two butane.
Butan 2-ol. Butan 2-ol, but there's a side group attached. I highlighted that blue.
Yes,
See,
sir.
methyl group is attached. No, that's one you have to write first at the beginning of the name. Any side groups or any substitute groups attached to the main chain, you have to write them first.
Then, sir,
Before you write butan 2-ol, you write 2-methyl. Not 2-methyl, 3-methyl. Because methyl group is attached to the third carbon. Then we write here 3-methyl. Is that clear? 3-methyl.
methyl, two butanol.
3-methyl without leaving a gap, you have write, don't leave a gap between methyl and L and B. 2-methyl butan,
Okay, sir.
what? 2-ol.
Two all.
Butan 2-ol. Yeah, that's how you write it. So there's only one side group attached. If there's more than one side group, you have to write them in the alphabetical order. Right. The next one, again, we have to first you have to identify the longest chain containing the functional group. First you have to number the chain 1, 2, 3. Actually, this OH group is attached to the third carbon. Okay, this is be shifted when printing. It should be attached to this carbon. 3. Then here 4. After that, you have to go down here 5, 6, because this is C6H5 is one separate group. that is called phenyl group. Actually, this is the phenyl group. This is the benzene ring. This is same as C6H5. It's called phenyl group. Phenyl. So this phenyl group attached to the fourth carbon. So that one you have to write first at the beginning of the name. So you write here 4-phenyl. How many carbon in the longest chain?
6.
6 carbon. 6. Then that means hexane. Hexane, but you can write hexane because it's not an alkane. It is not an alkane. You can write hexane. So it should be hexanol, but you can write
Okay, sir. Oh,
it's
phenyl,
hexanol, but
hexane.
hex actually hexane 2-ol. Hexane OH is attached to the third carbon. Hexane 3-ol.
3 also.
3-ol because OH is attached to the third carbon. Hex because of 6 carbon. All because of alcohol. 3-ol because alcohol group or the OH group is attached to the third carbon. Is that clear?
Yes, sir.
Now that means imagine now sometimes in the paper they can give the name and ask you to write the structure, to draw the structure. Imagine you are given this name in the exam, then you should know how to build this structure. Example, you have to check hex, then you write the carbon chain 1, 2, 3, 4, 5, 6, 6 carbon in the longest chain. Hexane. Then the third carbon you have what? OH group. Either from left side or right side you can select the third carbon. After that, then to the fourth carbon, okay, you can write here 1, 2, 3, 4. So you can see the fourth carbon, there's a what? Side group attached phenyl group, C6H5 or benzene ring. Then you have to fill the rest with what? Hydrogen to make it 4 bonds around each carbon. So this is CH3, this is CH2, this is CH, this is CH, here CH2, here CH3. So that's then you get the same. You should, because you can turn this any direction you want because this is L-shaped here 5 and 6, but if you only can keep it straight and put the OH to the other side, you can bend it or any direction you want, but you should get the same structure. Therefore, if you are given the name, you should know, you should be able to build the structure also. Mostly in the exam they'll give the structure and ask you to write the name. Okay.
Okay, sir.
Then number 6. Number 6 also alcohol. Can you try it like first can you make a small effort and number the chain and check how many side groups, and it doesn't matter if you get wrong, but I want you to, because your thinking ability also should improve. If I directly give the name, then you are just copying down this. So you know the method, right? Procedure. You have to select the longest chain containing max the functional group as well as the maximum number of side groups. When you number this, OH group should get the lowest number. 1, 2, 3, 4. So I can go straight, then you get how many carbon? 5, 6 carbon. I can go this way. If you go straight away, like here 5, 6, whatever, this entire thing become one side group, but it's very difficult to label also. Only one side group. But if you go down, then you will get ended up with 2 side groups. But carbon chain will be 6. Either you go straight or down L shape, carbon you get 6. But here you get, I'll highlight, there are 2 substitute or side groups here. One is a methyl group attached to the 5th carbon. The other one is ethyl group attached to the 4th carbon. Okay, so that is the longest chain contains 6 carbon. Is hexanol. Hexanol, but actually hexane 2-ol. Hexane 2-ol means to the second carbon, OH group is attached to the second carbon. OH group is attached to the second carbon, hexane 2-ol. But before you write hexane 2-ol, you have to write the side groups at the beginning of the name according to the alphabetical order. So this is methyl group, is one is methyl group, the other one is ethyl group. What should come first, ethyl or methyl? Alphabetical order. 4-ethyl or 5-methyl?
Sir, 4 I think, sir.
Yeah, it's 4-ethyl because alphabetical order, ethyl should come first. 4-ethyl, then after that 5-methyl. And after that,
6.
6 means hexane.
Yeah, hexa 2 whole.
Hexane,
2
2 all. Yes, correct. Hexane 2 all. That's how you write the name. Because if you should be able to get the same structure by looking at this name. Opposite of this also reverse. That also should work. Because if your name go wrong, then you will not be able to get the structure again by looking at the name. Then next on number 7. Next page. Number 7. Okay, this one. So how from which end I should start numbering? Giving lowest number to the lowest group.
from CH3, sir. You must start from CH3.
1, 2, 3, 4, 5, 6, 7. So I can go up to 7 carbon. It should be a continuous chain, right? You can't break the that number in the middle. You can't break.
7 carbons mean heptane.
Yeah, it's heptane.
Heptane. Okay, sir.
Heptane 2 all. Heptanol, but since OH group is attached to the second carbon, then we call it heptane 2 all. Now, okay, what are the side groups or the substitute groups attached to this? One is phenyl group, the other one is bromo, and the other one is methyl group. There are 3 side groups attached or substitute groups attached to this. So, this okay, I'll write here the name near the names also, then you can select the
So
alphabetical.
then we must start from 4Br.
For bromo,
For bromo.
means bromo, and this is phenyl. Phenyl, methyl, and bromo. These are the 3 side groups. Phenyl, methyl, and bromo. Those are the 3 side groups. What should come first? Bromo.
For bromo.
For bromo.
Then for phenyl.
Yes. For phenyl.
5
No,
methyl.
no, 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 no. Alphabetical order after methyl of M O P come first. Alphabetical order. LMNOP in A B C D F G.
Then 5 methyl for phenyl.
Yeah, yeah. 5 methyl. 4 phenyl.
5 methyl for phenyl. Uh,
4 phenyl.
heptane 2.
Yeah, very good. Heptane 2. When you write heptane, no, don't leave a gap here between phenyl and heptane. Heptane 2. Correct. So it's not hard, right? I mean, you don't need to do theory to do this kind of thing. Okay, then next one. Number 8. Shall I erase the screen?
Yes, I can erase.
You got holidays, right? School?
It's until June 6th.
Yeah. You are from Isipatana, no, Royal? What is this?
St. Peter's, sir.
St. Peter's. No. Okay. Then you can write here this one. Okay. This one. What is the functional group? So OH group should give the lowest number. When you number in, so it's 1, 2, 3, 4, 5, 6. Now You have phenyl group also there, and you have chlorine also there. I'll highlight the side groups. Methyl also there. Methyl, chloro, and phenyl, and plus there's a double bond also. Now that also you have to consider when you are writing the name. The double bond also there at the beginning of the fifth carbon.
So they should come hexene.
Actually, it's now without double bond, it's hexanol.
Yes, sir.
Hexinol. 5 in there, 5 in 1 all. Because now you can write now. Okay, forget about the side groups now. If we take here hexane, actually you can write hexane because it's an alkene. The alkene double bond also there. You can write hex 5 in.
Right.
5 in means at the beginning of the fifth carbon there's a double bond. Hex 5 in 1 all. Why 1 all? One OH group is attached to the first carbon. OH group is attached to the functional group is attached to the first carbon. That's why 1 all. Why 5 in here? At the beginning of the fifth carbon, the double bond is there. Why
Okay.
here? Why hex here? There are 6 carbon in the longest chain. So that's how you end the name. The suffix will be like this.
Okay.
Now you can see now everything perfect, right? You can find the location of any of this with the double bond or whether it's OH group, you can find exactly the location. And now can you write the name?
So 4-chloro,
Okay.
4-chloro, 2-methyl,
Hmm.
4-phenyl,
Hmm.
hex 5 in 1 O.
Yeah, correct. That is the correct one name. So I can write here now 4-chloro, 4-chloro, then 2-methyl. After that 4-phenyl. After that you can without leaving a gap you can write what? Hex
Hex 5 in 1 O.
1 in 1 all. Correct. 5 in 1 all. It's not necessary to write. If it is one, we skip that and just write hexanol, but anyway it's better. Hexan 5 in 1 all because our new syllabus is the most accepted method. The number 9, can you guess now?
Number 9. So will you give me 2 minutes?
Yeah, sure.
So what is CH2, sir?
No, actually, it's the double bond where alkene.
Okay, sir.
So when you are numbering, okay, wait. You have to be very careful now. You have to start numbering from one end. Now you can go like this 1, 2, 3, 4, 5, 6. Because double bond. This was very important. When you are selecting the longest chain or when you're numbering the longest chain or the main chain should include any double bonds or triple bond. You can't keep them out and do it. So when numbering the chain, longest chain, double bond, carbon should be there in the longest chain. That's why I went. Otherwise, I can go 5, 6, 7 up to 7 carbon. Did you get the point now? What I'm telling? Now I can go the straight like then I am getting more carbon here. I see 6 and here 7 and here 8. I think.
Then
But I can't do.
octanol.
Yeah, it will become octanol, but I can't do that because my
Then
longest chain should include double bond.
yes.
Bond I can't keep as a side group. Double bond should be in the longest chain. That's the main thing. But this is also wrong. Why? My numbering is wrong here. The reason is this. I have to start from this end. 1, 2, 3, 4, 5, 6 like that because then the OH group get number 3. The blue one. But red one OH get number 4. So in which method number in the OH get the OH group get the lowest number, the blue one or the red one?
In blue one, sir.
Blue one. So therefore I'll erase the red one. When numbering you have to give the lowest number to the functional group. And the double bond also get the lowest number there. That's the best one. So I'll write here now when number naming this 1, 2, 3, 4, 5, 6. So I'll highlight the the side groups of the substitute groups. There's a methyl group here at the figure, the fifth carbon, and there's a propyl group at the second carbon, and there's a bromo also. So you have to write those three groups according to the alphabetical order, and you have to indicate to which carbon atom they attach also. And after that, you can write just hexane. This is ene, no, like the previous one. You can write here actually the last part. The name ends in like this: hex.
X in
One in. You can write just in one in
3 all.
3 all, no, like that. Yeah, correct. X1 in 3 all. But before that, you have to write side groups or the substitute groups according to the alphabetical order.
So then it will come 4 bromo, 5 methyl,
Oh, bromo.
and
Propyl group. This is called propyl.
propyl.
5 LM. Yeah,
5
then after that
methyl,
methyl comes. Yes. 5
5
methyl.
methyl. Then 2 propyl,
Huh?
2 propyl, hex 1 in 3 all.
2 propyl.
Hex 1 in 3 all.
1 in 3 all. Yes, correct. Yeah, correct. Very good. 3 all. Right, like that. Good. I think you understood now. Now, number 10 also can you do without my help? Shall I erase this too?
Okay, sir.
Can you try this without my help? First.
Okay, sir, I'll try.
Right. So what should come first? Bro.
4 bromo,
Yes.
4 bromo, 2 methyl,
Hmm.
4 phenyl,
Right.
hexa,
Hexane, no?
hexane 2
No
O.
double bond. No double bonds or triple bond. Therefore, just write hexane, no?
Hexane 2 O.
OH on the second carbon. Yeah, very good. Right. Hexane 2 all. Very good. Yes, that is number 10. Anyway, this one you have to do it, learn it by doing it, because there's no short method. You can, they will never ask in the exam to write the standard rules that must be followed when writing the names. But without keeping those rules in your head, you can't write the name. You will get stuck in the middle. Therefore, no need, they don't need to ask separately that. Right. Then let's move to the next one.
Okay, sir.
Now that's all alcohol. Now you understood that's all alcohol up to 10. Next group of compounds, aldehyde and ketone. I told you aldehyde always at the terminal. This aldehyde group is at the terminal, but ketone, aldehyde means you have this group. Aldehyde means is C double bond OH. So it always carries one hydrogen atom, and this is called carbonyl carbon. This C double bond OH, it's a very popular one. This is called carbonyl carbon. Carbonyl group. Right. So it's carbonyl group now. any aldehyde, the aldehyde group is always at the terminal. It cannot come to the middle anyway. So I'll write here 1. Okay, let's see the numbering now. We'll give you the lowest number to the side group. 1, 2, 3, 4. Right. So what is this butanal aldehydes? The name ends in L. Name ends in L. This one name ends in on. So this is one. There are 4 carbon. This butanal. Or else you can write butan. One or no problem. So aldehyde. What is the name? I have to try the name. I'll display here. Butanal. Butan 1L, or you can write butanal. Butanal. Either butan 1L or 1.
So, which method is suitable for the final exam?
First one, that butan 1L is better. But anyway, it's not necessary to write 1L because anyway, it's that will never come to the middle. Any aldehyde, aldehyde group is always at the terminal. Therefore, all the aldehydes you get 1L, 1L. Therefore, it's not necessary to write 1L. Wait, I'll show you that in the resource book also. Then it's easy to understand. This is the resource book. Let's see whether how they have labeled an aldehyde. How they have labeled an aldehyde. Now you can see this carboxylic acid and this is pentanal. Here, can you see here? 1, 2, 3, 4. The right side one. Pentane plus L, then is pentanal.
Yes, it's there.
But it's not necessary one, right? Because anyway at the beginning, any organic compound aldehyde group is there, it should be at the beginning. Okay, so that's why, that's the reason. Therefore, it's not necessary to write. But if it is alcohol, definitely you have to write it to which carbon it is attached. But carboxylic acid and aldehyde is not necessary to indicate the functional group to which carbon it is attached. One more example. Now you can see this is 3-methyl butanal. So this is no need to write butan 1L. Carboxylic acid and aldehyde always at the terminal. Therefore, it's not necessary to write. But others OH group, yes. Now you can see here this one. It is pentane. Pentane. So this is pentanal, right? Pentanal. 2,4-dimethyl pentanal. Aldehyde L. This one very important. Now here you can't write just, look at this one. You can't write just pentanol. Why? Pentan 1-ol, because OH group can be anywhere on the longest chain. Is that clear, everyone? I mean, is that clear?
Yes, sir, it's clear.
The left side one is, look at the last one, 2,4-dimethyl pentanal. Actually, pentan 1-ol. 1-ol, yes, because OH group can be anywhere in the chain. But the aldehyde group, you have to definitively show that to which carbon is attached. Right. Yeah, given some examples in your resource book. Also, have you got this resource book? This one? Not yet, no?
No, sir. I think it is grade. It comes to grade 13. Still, I have grade 12 resource.
Grade 12. Yeah, he's under grade 12. Third term.
But I don't have it, sir. I guess.
Yeah. Yeah, you can get this from ni.lk website, or else you can I can share with you. This one actually unit 7 to unit 10 organic chemistry. That is your third term work, grade 12 third term, because from 11 to 14 grade 13, because they are the number of lessons less, but in one lesson there's a lot. You can see when you write the aldehyde, yes, you have to indicate to which carbon it's attached. So I wanted to highlight here. here 4-hexynyl, X4-inyl. Okay, let's see now this one. What is the last one we did? Number first one I did right. Okay, so this one you right.
Yes, the first one complete. Now
Yeah.
second.
Yeah. So this one just butanal, right? Butanal. If it's not necessary, right? Butan 1L not necessary. Number 2, second one. 1, 2, 3. But second carbon there's a side group. That is
Uh, 2-methyl propane,
prop
propanol.
propanal. Propanal.
Yeah.
2-methyl propanal. Ethanol, ethanol, butanol, pentanol, hexanol, heptanol, like propanol. So propane is 3 carbon. But propanol, if you only write propan 1L, no problem. They will consider that, but it's not necessary to write. Anyway, it's 1L in any compound or if aldehyde group is there. Right. So this is how you get it. 2-methyl propanol. 2-methyl propanol. If you only write propan 1L, but it's not necessary because anyway it's 1L, 1L like this. It doesn't make because C double aldehyde group anyway at the beginning of any organic compound. There was a one here. Yeah, this one. So it's hexanal, hexynyl. Right. And let's move back to the next one. Number 3. Can you try it alone? Third one.
So 4-methyl pentanol.
4-methyl. Yeah, very good. 4-methyl pentanol. Correct. Correct. 4-methyl pentanol. 4-methyl pentanol. Right. Then number 4. Shall I read this?
Okay, sir.
Number 4. This is not an aldehyde. Why? So this is called, actually these are called alkyl groups. So there are 2 alkyl groups attached to this carbonyl carbon. Methyl group, and actually they are not side groups. Okay, I just highlighted. They are not side groups. So if you go for the longest chain, the lowest number should come for this is called the ketone group, right? Ketone 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. So it's butane. Now remember this is called ketone group. This R means alkyl group, so R can be ethyl group, methyl or any other group. Now this is called, if you only can put an arrow and label this is called carbonyl carbon. This carbon attached to the double bond oxygen, so that is called carbonyl carbon. And this is a ketone group. Because if one side, okay, look at this. If you get COH, then it's aldehyde. If you get COH, is aldehyde. If you get COR, And this side not hydrogen, you get here R. R means a methyl group. This side you can get ethyl group. Both side alkyl groups. Then it becomes a ketone. It becomes a ketone. So this is called carbonyl carbon. So carbonyl carbon. That's a ketone group. So the ketones, the name ends in on. Propanone, butanone, pentanone, like that. The name ends in on. O-N-E. O-N-E. So this one we can write what, but that double bond oxygen, that carbonyl carbon can be anywhere in the chain. Therefore, this one, not like aldehyde, you have to indicate to which carbon this carbonyl, that oxygen is attached. Oxygen double bond is attached to which carbon. Okay, let's see. Now then you can write here. Yeah, butanone, but you can write here butanone, not just butanone, butan 2-on. Butan 2-on. Why 2-on?
Because oxygen is attached to second carbon.
Second carbon, yes. That also you have to indicate, because sometimes you can attach the oxygen to any other some other carbon. That's right. If you only can write just butanone, but the most correct one butan 2-on. And now the other one very important because it's a bit more complex. You have the ketone group and aldehyde group both. This is the ketone group, this is the aldehyde group. So you have both aldehyde group and ketone group. Now the problem is what? Whether to name this as an aldehyde or a ketone. What are the main functional group? There are two functional groups. When there's more than one functional group in the chain, we have to go for the priority, the order. I have given that in my short notebook as well as the resource book. I have this there. Okay, wait, I'll show you that. In the resource book also given this. Yeah, this one. According to their priority order. Can you see this screen? According to their priority order. So what should come first? Higher priority, aldehyde group or the ketone group? This is aldehyde group.
So aldehyde is first.
Yeah, that means when the ketone is there, when both ketone and aldehyde group is there, you should name that as an aldehyde. Ketone group CO bond become oxo. Right? Oxo, and the last name, that is the suffix will be on. It's a ketone. Oxo is that is taken as a side group. Side group. The ketone, because you can't name the compound as ketone and aldehyde both. Ketone and aldehyde both. Right, now let's see. So therefore, when both aldehyde group and ketone group is there, we name that as an aldehyde, right? We name that as an aldehyde, not a ketone. Ketone that become side group or the substitute group. Substitute group, oxo. Right, now let's move back to this one. Okay, so we had to the lowest number to the functional group aldehyde group. So I'll start numbering from this end. 1, 2, 3, 4, 5, 6. So there are two groups here. This is methyl, this is methyl. Then you get 4,4-dimethyl. What is 4,4-dimethyl? 4, 4, You can write 4-methyl 4-methyl. No, we write 4,4-dimethyl. When the same group is repeated twice, imagine if it is 4,3 or 4,5, then you can write 4,5-dimethyl. So this is 4,4-dimethyl. Why di here? There are two methyl groups. 4,4-dimethyl. Now oxo also there. But this is how it looks. Oxo. So what oxo? 3-oxo. To the third carbon, there's a oxo group, double oxygen group. 3-oxo. What should is that correct? Alphabetical order. When you, if you only can note down that in a short notebook, when writing the when we consider the alphabetical order, we don't you consider di-tri. So the name of the side groups, the alphabetical order of the name of the side group, methyl. So we don't consider the 2 or 3 or whether it's di or tri. It's not. They are not considered when predicting the alphabetical order. Name of the substitute group. So what should come now? 4,4-dimethyl, 3-oxo. What the rest is hex, right? Hexanal. Hexanal. Oxo and hex, no space. Hexanal. No need to write hexan 1-al because anyway aldehyde is always at the beginning. Carboxylic acid and aldehyde always at the beginning because it always begins with number 1. Yeah, you have put 3-oxo. After 3 also you have put a dash. Oxo hexan 1-al, but we write just hexanal. Because no need to write this. So anyway, it's become 1-al, 1-al, 1-al. Any compound is at the beginning now. Anyway, it's the first carbon in aldehyde group. Therefore, we don't. Then number 6. How to write this? Can try without my help first.
Okay.
This is also aldehyde. Okay, this group is aldehyde. Don't confuse with the way they have given here. It's same as if you want. I'll draw it again. This one you can draw like this: C double bond O H like this. Same thing. It's aldehyde group. Can you try? Phenyl is there. If you want, I'll highlight the substitute groups to predict the alphabetical order. CH3 is and this C6H5 and this also CH. These are the 3 side groups. Functional group is the black one. The highlight. Yes, can you just post the answer on chat or can you try first? Okay, 3,4. What did you put? 3,4-dimethyl, 3-phenyl, hexenal. Hexenal. Is there a double bond? No double bond, right? Longest chain, no double bond.
They must have hexanal, no, sir?
Yeah, just hexenal, not hexenal, hexenal. So you get here 3,5-dimethyl, 3,5-dimethyl, then 3,5-dimethyl, 3-phenyl, hexanal, hexanal, hexanal. That's how you get it. Then number 7, can you try alone?
Okay, sir.
It's a ketone, now be careful. Yeah, you put 3-chloro, 2-methyl, 3-chloro, 2-methyl, 3-phenyl, hexanol. Right, ketone you have to put whether it's 2 on or 3 on or 1 on, because ketone, the double bond oxygen, it can be anywhere. It will not always at the beginning, like, or terminal. Aldehyde group is always at the terminal, like at one end, but ketone group can be anywhere in the chain. Therefore, that one you have to write hexane or heptane 3 on or 2 on. You have to write that. Just you can't just write hexane on or heptane on. And the other most important thing when numbering, can you remember I told you uh, functional group should get the lowest number, not the substitute group. When you start numbering from this side, Sijan, so you get functional group get number 4. But if you start numbering from the other side, from bottom, double this one get, what is the number you get? 1, 2, 3. What is better? Blue one or red one?
The blue is better, sir.
Blue, yeah, because the functional group should get the lowest number, not the substitute group. Therefore, the blue one, yeah. Then you have to write. Can you try again? Phenyl, chloro, methyl. And then now we can write it. Can you again try it and post the answer in chat? Yeah. 4-chloro, 5-methyl, 4-phenyl. Very good, very good. Yes, that now is perfectly correct. Hexane trione. Very good. Yeah, correct. So I'll write here 4-chloro, 4-chloro,
5-methyl,
5-methyl, 4-phenyl, no? Hexane, hexane 3 on. I think you also get the same thing, right? That's the answer. Yes. Then next one, I erase this. Shall I erase this?
okay, sir.
Then number 8. Okay, this is a bit more complex. Can you try? Double bond. Okay. Longest chain should include double bond as well as functional group both. If you want to write that in your short notebook, when selecting the longest chain, it should include both double bond as well as the carbonyl carbon. That means the ketone functional group carbon. Double bond also carbon also should be there. The functional group carbon also should be there in the longest chain.
Excuse me, sir, shall I like shall I do the eighth one alone?
Right, what did you ask?
Sir, shall I do this alone? So this alone and send the answer, sir?
Yeah, sure. That's better. Okay, you put 2 ethyl, 6 methyl, 4 propyl. Ah, yeah, that methyl, I forgot that. Methyl group. Now one mistake that we have done, it is not a ketone, it is an aldehyde, number 9 I think, 3,6 dimethyl hept, and it's not 17, Sushant says 16 because the double bond begins from the 6 carbon. Now the latter one, the former one you had right, 6 no? Double bond begins with the 6 carbon, therefore 6.
In the number one also there is a oneness, sir. At one.
No, this is an aldehyde now.
Okay, sir.
It's like this no, COH ne here.
Yeah, see you. It's
If it is CO both side, if you have the carbon, then it's ketone. Like this. This is ketone. This is aldehyde because if one side hydrogen, then definitely is aldehyde. If both side carbon, then is ketone. So this is aldehyde, therefore the name ends in L. So it's enal, 6 enal, because of double bond at the beginning of 6 carbon. L, we don't write 1 L because anyway aldehyde you get number 1 in an organic compound. Aldehyde you get number 1. If it is aldehyde, we never write the number. Okay,
okay, sir.
let's move. Shall I erase this?
Okay, sir.
The next one, number 10. Can you try first? Yeah, you can post the answer on chat now.
Okay, sir. I'll post the answer.
Yeah, you have put 2,6 dimethyl, 2,6 dimethyl. 5 all no 5 hydroxy because it's a side group ne? When OH becomes side groups we call it hydroxy. because okay, look at here the functional group, the priority. When you have both aldehyde group and the OH group, what is the higher priority? OH group, you can see the position here. OH is here. Where, sorry, OH is here. CHO aldehyde group is what above that, right? Can you see the higher the order, priority order? Aldehyde and position of the alcohol. Alcohol is below aldehyde. Therefore, when it comes to when you have both aldehyde group and the alcohol OH group and the aldehyde group both in the same chain, so you give the priority for the aldehyde group, and OH can be considered as side group here, hydroxy. OH become hydroxy and the aldehyde become the al. Look at here the priority order.
So
Because
they must come 5 hydroxyl, 2,6 dimethyl, 4 phenyl, oct 1 Al.
yeah, what should come first? Hydroxy or methyl? Dimethyl.
Uh, Hydroxyl, sir.
Yeah, alphabetical order, hydroxy should come first. Then you can write here 5 hydroxy,
Then 2,6 dimethyl,
2,6 dimethyl,
4 phenyl,
4 phenyl. Yes,
octan 1 Al.
octan,
Octanol,
oct, just octanol because aldehyde no need to put the number. Ne?
yes, octanol.
Octanol, octanol. Yes, 5 hydroxy octanol. Okay, because you have to you can't memorize this. You have to learn it by doing it. You have to practice many questions. But anyway, this is like functional group wise. I have prepared these tutorials, but later you have to practice all the last 30 years questions under IUPAC organic names. Then you will get more confidence. So that also I have already shared with you, I think. Okay, after that I'll come to this. So number 10, then number 11. Shall I erase this?
Okay, sir.
Okay, then can you try the last one? This one. Let's try without my help and post the answer on chat.
Excuse me, sir.
Yeah, okay. Any doubts?
Sir, what is this CH2CH3?
That is ethyl group. So these are the side groups, yeah, ethyl group, and then you can get a methyl group, phenyl group, and then bromo. All these are side groups or substitute groups. What is
Sir,
the
hydroxyl
yeah, okay, that also. Now that's the problem. Now here you have to select which one has the functional group. The ketone or CO group is ketone group with both side carbon. Ketone
yes.
group or alcohol, which one the highest priority? Like you can check in the short notebook. I also have given organic resource book, also page number 17. You have the priority list. Look at the position of this.
Ketone is higher
OH,
than alcohol, sir.
ketone is higher, then OH become hydroxyl.
Yes, sir, hydroxyl.
In OH, I'll highlight green because OH become the side group because higher priority for the ketone. Then you can start numbering, giving the lowest number to whom, to the functional group. So what is this? You can start from top, bottom to top, 1, 2, 3, 4, or you can go the blue one. I will go this way. If you number 1, 2, 3, 4, and this one you get number 5, no? 1, 2, 3, 1, 2, 3, 4, number 5 here. What is
Yes.
blue or red one?
The blue is,
Yeah, blue one is better, correct.
so then it will come 3 ethyl, 3 ethyl, uh, 5 bromo.
Yeah, it's correct. The only thing is what you have to write octane 4 on because you can it can be anywhere now. Then you have to indicate to which carbon that double bond oxygen is attached. It's 4 on or octane 4 on. Okay,
Okay, sir.
that's only difference. So octan for on. If it is aldehyde only, aldehyde and carboxylic acid, that's what we're going to discuss next. Carboxylic acid, that's only, we don't need to mention the number. With the alcohol, we have to mention the number. Then ketone, we have to mention the number to which carbon is attached the functional group. Aldehyde and carboxylic acid, not necessary to. Okay, shall I read this? That.
Okay, sir.
So that's all this one. And then 7.4 also I have shared with you, 7.4 and 7.5. This is carboxylic acid and derivatives. So the carboxylic acid, you can see the name ends in oic acid here. Can you see it has a higher priority? Look at here, it's at the highest priority, no? Look at this list, the priority list are higher. So oic acid, the name carboxylic acid, and it's the name ends in oic acid suffix. Hexanoic acid, pentanoic acid, methanoic acid, ethanoic acid, like that. So we don't need to write 1 oic, 2 oic, because it's anyway at the beginning. In any compound, the carboxylic acid will be at the beginning of the chain. Anyway, it's carbon number 1 always. Right? So then hexanoic, heptanoic, octanoic, like that you can keep. So let's see one example of 7 point for the first one. What is the longer? Now when you are number in the chain, you should get the lowest number, you should give to the functional group. Functional group will be COOH group. 1, 2, 3, 4. Now third carbon, there's a side group or the substitute group. So that is methyl, right? So this will be 3 methyl. Yes, 3 methyl. Heck, this is butanoic acid. Butanoic acid. Butanoic space acid. Butanoic space acid. Is that clear?
Yes, sir.
But no need write 1 oic, 2 oic, right? Because anyways, number 1, COOH is always at the beginning of the chain. It will never come to the middle. Always when you start numbering, you have to give the number 1 to the COOH group or carboxylic acid group. So let's see number 2. Can you try alone? Slight change. So 1, 2, 3, 4, and here this is phenyl group. This become what? 3 phenyl. Butanoic acid. Hmm? Okay.
Okay, sir.
And number 3. Number 3. I would write that you have to number the chain first. 1, 2, 3. Should I go straight or should I go L shape down?
L shape, sir.
Yeah, because we get I get more carbon in the chain, right? Yeah, that one. Because you have to select the chain with the maximum number of carbon atoms. Then is methyl group, and here also methyl group.
Then 3, 4 dimethyl hexanoic acid.
Yeah, very good. That is correct. 3, 4 dimethyl hexanoic acid. Correct. Next one, number 4. Can you try again? Now they are also the highest priority carboxylic acid group, and then all the other groups become side groups. And double bond should be in the longest chain. Can you try this first?
Okay, sir.
Right now you have sent to the chat 6 ethyl 5 hydroxy 2 methyl octinoic acid. Yeah, correct. Small change. Right? You write oct, which at the beginning of which carbon the double bond there. That's you have to mention here. That's the only thing. The rest is correct. So I'll quickly write it. 1, 2, 3, 4, 5, 6, 7. I'll highlight the side groups. Hydroxy, 5 hydroxy, 2 methyl and 6 ethyl. 6 ethyl. So then you have to try the alphabetical order. What should come first? Ethyl. 6 ethyl. Then
5 hydroxy,
5 hydroxy,
2 methyl,
2 methyl,
oct, 6,
yeah, so it's hepta, no? 8 to 7,
7 heps,
6, hepta, no? Hept.
hep,
Hept 6 in
6
enoic acid.
in
Enoic. Why en? Because of the double bond. Oic means carboxylic acid. 5 enoic. En because of the double bond. Double bond at the beginning of the 6 carbon. Okay.
okay,
Due, due to double bond you get En. Oic because of carboxylic acid. 6 because of the double bond at the beginning of the 6 carbon. And in the suffix, your last one, I think is small change you have to do, the rest is correct. Okay.
okay, sir.
Then we'll go for the next one. Shall I read this? Done.
Yeah, sir, done.
Then number 5. Can you try this first?
Okay, sir.
So when COOH and oxo both there, then this become oxo, right? Because we name this as a carboxylic acid. CO bond become oxo. Okay, you have sent 4 bromo, 3 oxo, 3 bromo, 4 bromo, 3 oxo, 4 phenyl, no? Octinoic. Now this double bond you have to tell which now it can be at the beginning of the 6 carbon, it can be at the beginning of 5 carbon. There are many other options now, the alternatives for the position of double bond. Therefore in the suffix you have to mention oct 5 enoic acid like the previous one. You got it? Everything else correct. Only the last part is small error. So I'll write it now. 4 bromo, 3 oxo, 4 phenyl. After that you can write 4 phenyl
Oct 5 enoic acid.
oct 5
Enoic acid.
enoic acid. Correct. En because of double bond at the beginning of the 5th carbon. Yeah, that's how you do it. So it's not hard, right? When you practice few examples, you get it, because you have to learn it by doing it, because they will never ask theory or to explain this. Either they give the name and ask you to draw the structure, or they will give the structure and ask the name. But MCQs also they can give 5 different names with small changes, then they'll ask you to find the most correct one with the structure. Right. Now that's all. This 7.4. 7.4, there's a small, the other part I'll discuss the next day number. So can you continue this at home? This nitro, right? You can look at the short notebook also, the names here, the nitro. The others, ethyl, and this is chloro. This one you have to name as a ketone. No, carboxylic acid there. This is oxo, right? Can continue now. Now you got the method.
Yes, I will continue.
So you try complete the remaining pages of this one at home. Acid chloride, no need that the last two here. Plus, if possible, I have shared this organic past papers also for 1995 onwards. 1995 onwards. Past questions, past paper questions from this IUPAC nomenclature of organic compound. This also you can try, right?
Yes, sir. Right.
Next week I'll discuss this and we'll finish it.
Okay, sir.
So then we'll stop for today, and next day you can join the normal time, the Wednesday 5 to 7 5 that time.
Yes, I can join.
Okay, we'll continue that time. So today I did this because we couldn't do the class on Wednesday. Right. Okay, then good night, and we'll.
Okay, sir. Good night.
Okay, God bless you.